Hey guys, I'm going to make an attempt to repair this Hewlett-Packard 410C VTVM. What's currently happening is that the ohms works okay. Here's a 10 ohm resistor, for example. I've got it on the R times 10 scale, and if I hook it up, it's pretty darn close. Probably just needs to be calibrated. The ohm scale is on the bottom here, and it's measuring about 9 ohms. But what doesn't work at all is the DC volts. So, for example, I've got some batteries here, and I connect some voltage to this. Basically, nothing happens. So, I went online to the Boat Anchor Archive and printed out all the documentation, particularly the schematics here. I figure I'll check the power supply first. Here's a closer look inside. It's built on several circuit boards that actually slide out, which is kind of nice. So this little board here has all the calibration controls. This board is the heart of it. And this thing is particularly cool. Turn the lights off so you can see what's going on there, is that these actually glow. These are optical cells. There's a neon light at one end and a photo cell at the other end. And that's part of how this thing works. It's something called a chopper. And here's the photo cells, and there's the neon lights. So it obviously is working to some extent, but something's not quite right. I'm going to see if I can take off these panels and get access to the power supply and check the voltages. Before I dig into that power supply, I went online and mentioned my problem, and I got a very good piece of advice to check the obvious things first, which is that there might be a break in the probe lead. So I unscrewed the end of this, and what do you know, the wire fell right out. So I'll try connecting the little stub that's left on here to an alligator clip. Well, what do you know, 4.5 volts dead on. I have 3 AAA batteries here for a total of 4.5 volts. So that was easy. I am still going to go through and make some checks and calibrate this though. And I want to check that one tube down in there. Plus, I'll give you guys a closer look at the inside to this because I think it's kind of neat. Here's a closer look at the insides of this device. Very, very well made. All aluminum construction on the frame. Here are the circuit boards. Everything's gold plated. Very cool. They use Sprague orange drop capacitors, very high quality. Here's a calibration board. And here's the power supply. There's a power transformer. Some rectifiers down in there. And a voltage divider network up here. And there's a power transistor used as a series pass regulator. And there are all the resistors to form the range function. When I took this apart, I found some bits of glass inside. I didn't think much of it at first, but then I discovered what they came from. Unfortunately, this resistor here is a very special resistor, 89 mega ohms, and it was encased in a glass tube, but that's shattered at one end. Hopefully that won't affect performance too much, but I imagine getting any kind of contamination in there can't be good. And a glass 89 mega ohm precision resistor, I suspect that would be very difficult to find. Made by the Victorine company, which I believe is no longer around. They specialize in making stuff like this, oddball components, especially high voltage stuff. Yeah, so that's about it. In the documentation here, they have a whole section on maintenance and calibration, so I am going to run through that and see if I can get that the ohms and the DC working even better. Here's what was inside that DC probe. It came apart pretty easily. I just used my fingers and unscrewed the ends. There's actually a 1 mega ohm resistor in there. It measures fine, so I'll keep that. And there's the solder connection that broke off. So I stripped a little bit of insulation off the end of this, and I'll solder it back on. The calibration procedure for the DC range is fairly simple. First thing is you turn the meter off, and you adjust this mechanical adjustment to get the needle right on 0. Turn it on, wait about half an hour for it to warm up. Short the DC V connector and the common together. And there's an adjustment on the back for 0 adjust. So tweak that so the needle is dead on 0. And then apply an accurate voltage. In this case, I got 50 volts going in. Got on a 50 volt range, and I adjusted this potentiometer here, the second one from the right. It says DC above it, to get the needle right on 5. So 50 volt range, right on 5. If I go to the 150 range, bam, right on 5. 500 range, bam, right at the 0.5 mark. So DC is working excellently, better than the senior volt-ohmist, but that's to be expected since this is a much more expensive device. So the next thing I want to check is the ohms. So I'm going to pull out some resistors and try testing them. To calibrate the meter for measuring resistance, first you short together the common and the ohms leads. Meter should be on 0, that's fine. Then you disconnect the two, and it's supposed to go to infinity, which is the far right. The ohms is the bottom scale here, but mine's way off to the right. So I need to adjust that ohms infinity adjustment down there. And let's see if I can get this. There we go. Almost. Right about there. Alright, now I'll pull out some resistors and see how they measure. I've got a precision 1.5K resistor attached, and right on the nose, 1.5. Here's the schematic for that AC probe that I'm missing. Originally it would have had a vacuum tube rectifier in it, which I'm going to try replacing with a modern silicon diode. I just drew one in here. I'll also need a 2600 picofarad capacitor, a 22 mega ohm resistor, and a 250 picofarad cap. Here's what the probe assembly itself looked like. It's kind of a big fat tube here to contain the vacuum tube and associated components. And there's the probe tip, and it also had an alligator clip for grounding attached right to the body of the probe. And the other end was a 1/4-inch stereo jack. I've been looking around my junk bins for one, but all I could find were mono plugs. So what I'm going to do just to try this out is I'll just tack some wires directly in to the plug itself. If I remove the bottom panel here, I can get easy access to it.